Alright, in this video we want to talk about something called the law of sines. And the law of sines is used for certain types of triangles, which we'll talk about. There's certain triangles where they'll give you the angles or they'll give you the sides, and you have to kind of decide whether to use this or whether to use the law of cosines, which we'll talk about in the next section. So two main things we want to do. First of all, learn how to find the area of a triangle when they don't give you the base and the height, because that's the usual way that you find the area. And then the second thing is to learn how to use the law of sines. So we'll talk about each of those. So first of all, if you see right here, this is the formula 1/2 base times height. That's the formula that's normally used to find the area of a triangle. But suppose that they don't give you the height. Okay, so if we look at this triangle right here, let's suppose they only gave us those side lengths A, B, and C. They did not give us the height. Here's what we could do. We could say the following. We could say, well, let's suppose we want to find the height right here. We can refer to this angle right here, and we could use trig. We could say, well, the acronym SOHCAHTOA tells us what sine, cosine, and tangent are. Let's look at angle A, and it looks like angle A has its opposite side to be the height of that triangle, and the hypotenuse is C. So if we're dealing with opposite and hypotenuse, that means we're dealing with sine. So we could say this. We could say the sine of angle A is equal to the opposite side, which is h. That's h right here. Not h for hypotenuse, but h for the height. Over the hypotenuse, which is c, because c is the hypotenuse of this red triangle that I just outlined right there. C has its hypotenuse. Okay, now we want to solve for the height, because remember, in this formula right here, in our area formula, we're assuming that they did not give us the height, and therefore we want to solve for it, because then we can plug in. So height is being divided by c, so we can cancel that by multiplying. And now we see that this is true. We see that height of that triangle is equal to c times the sine of A, and that gives us our area formula right there. 1/2 times BC times sine of A. Okay, that formula works for the following scenario. It works for when you have a side, you have an angle, and you have a side. So the angle is between two of the sides of a triangle. Okay, and that the name for that, by the way, it's called a side angle side triangle, SAS. Okay, that's the only case when it works, when you have, and this is what this means, an included angle. So the angle that we're dealing with is included between two sides. Okay, so let's try this right here. We have to first of all make sure that the angle is included between two sides, and it is. There's a side, and the angle is included between them. So we could say 1/2 AB sine C. And in this case, side A is right here, side B is right here. The letters don't really matter. It just so happened that C was the angle. But if A had been the angle, you would just replace that with the letter A. All that matters is that we're using an angle between two sides. So you get 1/2 times side A. Doesn't matter which one we use. Let's say it's 8. The other side is 9. And the sine of the angle is 104 degrees. So 1/2 of 8 is 4. 4 times 9 is 36. And then you're going to get 36 times the sine of 104 degrees. And when you plug that into a calculator, it winds up being about 34.9, in this case, centimeters, or square centimeters, because that's the unit they gave us. So 34.9 square centimeters would be the answer. Actually, I'm going to pull up the calculator so that we can use it later on. But again, the idea with the law of sines is that, or sorry, this is the idea with finding area. The idea with finding area is that you need to have an angle between your two sides, which in this case we did. Alright, so this would be done the same way. The only difference is they didn't give us a picture. So let's start by drawing the picture. So we have triangle ABC. It looks like this. They tell us angle A is 31, side B is 18, so that side is opposite to angle B. And side C right here is 22. So that means the area is going to be 1/2 times the two sides multiplied, so 22 times 18 times the sine of 31. Half of 22 is 11, and 11 times 18 is 198. So 198 times the sine of 31 degrees, and that turns out to be equal to 102 square meters. Okay, the law of sines, you can actually get it from using that formula that we just talked about. So if you look at the way they set this up, they're saying let's multiply everything here by 2, because they all have a half. So if we multiply 2 to all these things, well, that means half of 2 is just 1, so these all have 1s. And then notice they all kind of have something similar. They all have either an A and a B or a C, or an A and a C. So that's why they're dividing everything here by ABC. And you can see these will cancel, leaving us with sine C over C. These will cancel, leaving us with sine B over B. And likewise over here. So the law of sines is this. It basically says that there's a proportional relationship between the sine of an angle and its opposite side. So the sine of angle A over its side equals the sine of angle B over its side, which equals the sine of angle C over its side. So let's apply that right now. And this is just to note that the reverse is true. If you were to flip all of those fractions over, you would still get the same thing. Okay, here's the thing to know. We have different types of triangles, and you might have seen these terms, or you might know them from geometry. And you don't really have to memorize when the law of sines applies, because you'll be able to see pretty quickly just from looking at this. But here's what this means. So side angle side means, suppose I have a triangle. We'll call this triangle ABC, and I tell you that the side, the angle, and the side have to be the same. And the question is, can I draw another triangle? So let's call this triangle right here EFG. Can I draw another triangle that has the exact same side, the exact same angle, and the exact same side, and yet somehow the rest of this triangle is different? So let's see if I can do that. Let's see if I can, instead of having the side look like this, let's see if I can kind of bend it off right here. Well, I can't do that, because then I'd have to change that side. I'd have to kind of bend it over here, and now I just changed that angle, and I'm not allowed to do that. So the idea with these principles right here, side angle side, and it's the same for angle side angle, for angle angle side, or for side side side. The idea is, if all that my restriction is, if I only have to be restricted on a side, an angle, and a side in that order, there's no other triangle that I could draw that is not the same as that triangle right here. Same thing with angle side angle. Okay, so let's try it with angle side angle. So let's suppose I have another triangle, and the angle, the side, and the angle have to be the same. Okay, so we'll call that again triangle ABC. Actually, let's use different letters because we already used ABC. Let's use LMN. The question is, can I draw another triangle? So I'll draw that in a different color. Can I draw another triangle that has the same angle, the same side, and the same angle, but somehow the rest of it is different? Okay, well, let's try. Let's see if I can kind of, instead of having the side go like this, let's see if I can kind of swing down here now. Well, I can't, because then I just changed that angle. So basically what they're telling you with those principles is, if you are restricted on any of those things, if you have a side angle side restriction, or an angle side angle, or an angle angle side, or a side side side, all triangles which have those restrictions are going to be congruent. They're going to be the same. Okay, so let's take a look at how that applies to the law of sines. Basically what the law of sines says, if you have one of these cases, if you have an angle angle side or an angle side angle case, you can use the law of sines to find a triangle. This last case, side side angle, is a special exception, and I will show you how that works afterwards. Okay, and then what we're trying to do here, when it says solve a triangle, solving a triangle means find the missing sides or the missing angles, depending on what's missing. So let's look at this case. This looks like this one. We have an angle angle side case, and so we said that we are able to use the law of sines on that. Okay, so just to recall, the law of sines says this. It says the sine of A over its side is equal to the sine of B over its side, which equals the sine of C over its side. Okay, so let's start with this. We have the sine of angle C, so the sine of 80 is over its side. Its side is equal to 3, and that is equal to the sine of B over its side. Now the reason I didn't pick A is because A has neither thing given to us. Okay, so we want to pick the things that we are given right here. So you just use sine of angle 45 over side B. And actually I spoke too soon, because they're giving us two angles here, so we could, if we wanted to, find the third one, because we know that a triangle has to add up to 180 degrees. So this angle, we don't know it, but we know that when we add that to 80 and 45, we must get 180. So this is 125, and if we subtract that from both sides, we would end up getting 55 degrees as our third angle. So we can always fill in a missing angle when we need to, if we've given the other two. Okay, so now how do we solve for B? Well, this is a proportion, and usually the way that you solve a proportion is by cross multiplying. So let's multiply these. So we have 3 times the sine of 45 degrees, and that's equal to b times the sine of 80 degrees. b is being multiplied by sine 80, so we will cancel it by dividing by sine 80. Okay, sine 80, you have to divide the whole thing, not just the 80 or the sine, because those are not separate. And then b is equal to whatever this is, 3 sine 45 divided by sine 80. So let's verify what that is right now. So 3 times the sine of 45, let's make sure we're in degree mode, we are. And then we're going to divide this by the sine of 80 degrees. And that should give us side B, and it's 2.15. So that means this side is going to be 2.15. It says round to the nearest tenth, so let's say 2.2. And now we can find A, because we have everything except for that. So let's find A. A is going to be the sine of 55 degrees over its side, which is right here. We don't know it. And let's stick with sine 80 over 3. That was side C. Reason I wouldn't want to use B, you could use it, but we did round it right there, so it's going to be slightly inaccurate if we use a rounded answer. 80 and 3 were exact. They didn't round them. So let's multiply these, cross multiply again. We'll get 3 sine 55 equals A sine 80. Again, we will divide by sine 80 to get our side A. And whatever this is the answer. So let's find that right now. And we can, if you hit second entry, that's going to bring back up what we had before. We just need to change this to 55. And A is equal to 2.5 if we round it. So that we've now solved the triangle because we have all 3 sides and all 3 angles. And that's what they mean when they say solve a triangle. Okay, here's the last case I want to talk about. This is, we talked about angle. That first one that we did was, that was an angle side. Okay, this one right here is an angle side angle. It's done the exact same way. Again, we can fill in that missing side by if we add these together, we get 107 degrees. And then if we subtract from 180, that will give us the third angle, which is 73 degrees. So now we have basically an angle side angle case. I just circled in that order. So that's an angle, that's a side, that's an angle. We would do it the exact same way though. So we could do the sine of 73 over its side equals the sine of 65 over its side, which is side Q. And then you would do it the same way. You would cross multiply. So we have 5 sine 65 equals Q sine 73. Divide both sides by sine 73. And then Q equals whatever that is right there. Okay, and it turns out to be, Q turns out to be 4.7. Okay, so that's done the same way. Here's the tricky case, or what's called the ambiguous case, and that is when you have a side-side angle. So I said before, if we had something like, let's say an angle side angle, okay, that means something like this. If I have this angle, this side, and this angle, can I draw another different triangle that has a different way? And again, you can try it, but there's no way to do it. Angle, side, angle, there's no way that I can kind of come off here or come off in an angle that, those are not going to be triangles, or you have to change the angle side angle. But with this case, with this third case right here, which is a side-side angle, notice that we have side, we have angle. The question is, can I draw another triangle that has the same side-side angle but a different triangle? And the answer is yes, you can. Here's an example. You could take this side and basically fold it in, and you keep this side length the same, you keep this side length the same, and you keep that angle the same, but that's clearly a different triangle. So there are multiple cases, and that makes it a little bit more complicated when we're finding sine and cosine. Okay? And we'll see why momentarily. Okay? Because basically it means that you could have multiple solutions to this, unlike, for example, this example or this example. We only had one solution for each of those sides. This case right here will give us sometimes multiple solutions or none at all. So the possibility is you could have 0, 1, or 2 solutions. I'll show you how to find each. We'll show you one of each case. Okay, so first case is this right here. It says in triangle RST, we'll try to draw this. R equals 105, so that's a little bit bigger than a right angle. So this is 105 degrees. Okay, and then it says side R is 9. Side S is equal to 6, and side T we don't know. Okay, and it says we want to determine whether it has no solution, one solution, or two solutions. There are kind of formulas you can memorize, but I recommend actually trying to solve this. Okay, so let's see if we can do that right now. So the sine of angle R, the sine of 105 over its opposite side, is equal to the sine of angle S, that's right here, over its opposite side. Okay, let's cross multiply these. We'll get 6 times the sine of 105 degrees equals 9 times the sine of S. Then we'll divide both sides by 9. And here's the important thing, the sine of S equals that, not S, but the sine of S equals that. So let's figure out what this is. Sine of S equals this thing right here. And then the question is, how do we solve for angle S if we know the sine of it? And the answer is we need to cancel out the sine by taking the inverse sine. That's the opposite. So we'll take the inverse sine of this. Here's the key thing, or here's kind of where the solution, where you might end up having multiple solutions, and I'll show you in just a sec. So first let's take the inverse sine of that. It was 6 times the sine of 105, and that's divided by, not multiplied by, but divided by. So let's clear that. Divided by 9. Let's make sure we type that correctly. And the inverse sine of that, so that gives us a 40 degree angle for side S. Okay, so let's fill that in. So we have a 40 degree angle right here. That is this side, and then we can get this angle right here by doing 105 plus 40 and then subtracting that from 180, and that will give us 35 degrees. And then finally let's find side T. So we could say the sine of 35 over this side right here, so that's side T, equals the sine of 105 over 9. And then we will cross multiply again, so we'll get T times the sine of 105 equals 9 sine 35. Let's divide both sides by sine 105. And T should be whatever this number is right here. Okay, so let's find that right now. So T is equal to 9 times the sine of 35 over the sine of 105 degrees. This should be equal to side T, and it's 5.3. Okay, so the question is, how do we know that there's not another triangle that has the same conditions? How do we know? And here's how you know. Okay, here's why, first of all, you might have another triangle. So it's based on this step right here. This number right here, let's figure out what that number is. 6 times the sine of 105 divided by 9, that's an actual number. And then we took the inverse sine of that. So let's just calculate this real quick. So let's see, this is equal to 0.64. Okay, so let me write that and let me explain why we might have a second triangle. So S is equal to the inverse sine of this number right here, which we just said was 0.64. What does inverse sine mean? Inverse sine means what angle has a sine of 0.64. So let's draw this circle like we did in the prior section, 12.3. And in that section we said that the sine is equal to like the y coordinate. So if you look at this circle right here, if this were a circle that had a radius of 1, okay, there are actually two places. So this, let's say this coordinate right here is 0, 1. This coordinate is 1, 0. This is negative 1, 0. And this right here is 0, negative 1. Okay, there are actually two places where sine could be positive. And I think in the last section we talked about an acronym which is all students take calculus. It's a way of remembering when each thing is positive. So all students take calculus. Remember that with a triangle we're dealing with 0 to 180. So 0 to 180, here's 0 degrees, and then here's 180 right here. So that means we could be anywhere in the first or second quadrant, and sine is positive not only in this first quadrant where all is positive, but also in this second one. So if we look at, for example, 0.64, because that's the number we're dealing with, if this y coordinate right here is 1, 0.64 might be roughly about here. That's roughly 0.64. But that means this y value right here is also 0.64. So notice if we draw these things right here, we have actually two angles. We have this angle right here that we found. That was the 40 degree angle, because that's That's what the solution was to that. We found angle S, and angle S was 40 degrees. But notice there's another angle that might also have that same sign of 0.64. Okay, and that angle is this one right here. It's this yellow one. Okay, how can we find that yellow one? We can find it by using something that we found called the reference angle, which you might remember. So the reference angle means that this angle here is the same thing. It's also 40 degrees. So how would we find, shouldn't have used yellow, let me use black instead. How would we find this black angle? That's going to be 180 minus 40, which is 140 degrees. So the other possibility is that the other angle that also has this exact same sign is 140 degrees. How do we know if that works? Well, here's an easy way to tell. If there's a second triangle, we're guaranteed that these three things are going to be a part of it. So let me just write this. We have side R, side S, and side T. We know that in our first triangle, these were the values that we got. We got 105, 40, and 35 from our first triangle. If there's a second triangle, we are guaranteed that this is going to be 105. And then we just said that this second angle here is going to be 140. How do we get 140? We did 180 minus that. And why do we do that? Because 180 minus 40 is this black angle right here. It's the other thing that has a sign of 0.64. Okay, so here's how you can tell that there's not going to be a second triangle. If you add these together, you get 245, and that's impossible because it's bigger than 180. Okay, so you're only going to have one solution for this triangle. There's no other triangle that you could draw that works, because if this angle is 105 and I do 180 minus that, I'm going to get something that gives me more than 180. Okay, if that's confusing or that's not clear, I think it'll become clear when we do a couple more examples like that. So let's do another one. Okay, this one says ABC. A has a 54 degree side, 54 degree angle, and its side is 6. Okay, B has a side of 8, and C we don't know anything about. Okay, so let's use the law of sines. So the sine of angle A over its measure equals the sine of angle B over its side, and then we'll cross multiply. So we get the sine of B. It's going to be 6 sine of B. We'll divide by 6. So we're going to have 8 sine 54 divided by 6. And now to cancel out the sine, we need to take again the inverse sine. And this may result in multiple solutions. Why will it result in multiple solutions? Because that thing is going to be, let's first of all see what that number is, and then we'll calculate it. Okay, so the number that we're concerned with is 8 sine 54 divided by 6. So 8 sine 54 divided by, whoops, not divided by 3, divided by 6. Okay, that's the number 1.07. And then we want to take the inverse sine of that, and you might already be able to tell what happens, but there's actually going to be no solution to this, and I'll show you why in just a sec. Okay, you get an error. So there actually is no triangle that has these measurements, and this is an example of no solution. Why is that an error? Why is there no solution? Well, I'll show you why. Okay, so this, remember, this number turned out to be 1.07. Okay, why is that impossible? Well, remember, the sine is equal to opposite over hypotenuse. That's what SOHCAHTOA means. So let's say we have a triangle right here, and I have some angle, and I want to know the opposite over the hypotenuse. Okay, so there's opposite, there's hypotenuse. So if you were to find the sine of that angle, that would be saying this. That would be saying find the opposite over the hypotenuse. And in this example, they're saying that's equal to 1.07. Here's the problem. This right here can never be greater than 1. It can't be something greater than 1. Why can't it be? Because the hypotenuse is always the longest side. So if this thing here, if that were greater than 1, that would mean the opposite is bigger than the hypotenuse. And that's impossible. You can't have an opposite side that's bigger than a hypotenuse. So if you get to this step, if you do the cross multiplication and this number turns out to be bigger than 1, you're going to have no solution. Okay, it's impossible. And you can see that's what the picture looks like. If you actually try to draw that triangle as you see it there, we drew it a little bit different, but this picture actually doesn't work. There's no way that you can close this triangle. Okay, this side of 6, it's like it's kind of missing a part out there. You can't close it. The reason that happened is because we're trying to find an angle that has a opposite, which is 1.07 times as big as hypotenuse, and that's impossible. Hypotenuse is the biggest. So sine can never be bigger than 1. So the inverse sine of something bigger than 1, that's an angle that doesn't exist. You can't do it. Okay, the last case is this one right here. Okay, so we have our picture drawn for us already, triangle ABC, and the question is, first of all, how many solutions is this going to have? So let's start to solve this right here. So the sine of angle A over its side equals the sine of angle B over its side. And B, they drew this a little bit kind of confusing here, so not confusing, but at least for now we don't necessarily know what this looks like. So let's draw it like this. ABC, here's 35, here's 20, here is 17. Okay, let's solve this. So we'll cross multiply, we'll get 17 sine B equals 20 sine 35. Then we need to divide by 17. Okay, and then to find out what B is, we're going to have to take the inverse sine. So let's do that. So the inverse sine right here will cancel. We'll take the inverse sine of this. First of all, let's find out what that number is. So 20 sine 35 divided by 17. Remember, if it's bigger than 1, it's going to be impossible because you can't have a sine bigger than 1. If it's smaller than 1, though, we'll have something else to do. So we divide that by 17. That equals 0.67. So we may have multiple triangles here. And let's find the inverse. So this is 42.4 degrees. Okay, so let's just write that down. So angle B should be 42.4 degrees, and then if we add these together and subtract from 180, that's going to give us our third side. So that's 77, so that's going to be 102.6 degrees for our third angle. Okay, and then you can find the third side by using the law of sine. So here's what I want to show you. Okay, let's take a look and see, is there potentially another triangle? So our first triangle, we had angle A 35, angle B is the first thing we solve for, and that's important because we're going to have to use that one. And then C, we found it after we found A. And then these sides were 17, this was 20, and then C, when you actually solve for it, let's see where that is. When you solve for that, you should end up with, I guess they don't give it to you here. So let's just do that real quick. We'll solve for angle, we'll solve for side C, which we haven't solved for yet, which is right here. So we could do the sine of 102.6 over its side equals the sine, let's say, of A over its side. And just to shortcut that, when you actually multiply this out, you're going to get 17 sine 102 divided by sine 35. So that is our, I'm just kind of skipping a couple steps there, but that's how you would end up solving for the missing side. So 102.6, and then we will divide that by the sine of 35, and this should give us side C, and it's 28.9, which makes sense. C is the biggest angle, so it should also have the biggest side. So 28.9. Okay, so this is our first triangle. How can we test to see if there's a second? Here's how you can do it. First of all, if there's a second, we have to have these things part of it because they told us for sure that those measurements are in our triangle. So if there's a second triangle, those are definitely part of the second triangle. Okay, how do we find out if those missing things just right there, if these can be filled in? And here's how you do it. We said that this number here, when we calculated just this number, it was 0.67. So let's draw like a circle right here just to verify this. So remember, sine is the y-coordinate. Up here the y-coordinate is 1. Okay, 0.67 is maybe about right here, but there's another thing over in this quadrant that also has a y-coordinate of 0.67. That means there are two angles that might have that sign. Here's one of the angles right here, and that's the angle we found. That was the angle, where is it, 42.4 degrees. You can see that's an angle in the first quadrant, so it's 42.4 degrees. What else has a sine of 0.67 though? And the answer is this red angle right here, which has a reference of 42.4. How do you find the red? You do 180 minus 42.4. That turns out to be 137.6 degrees. Okay, so 137.6. So you might remember the other example we said. Okay, in the other example we said, how do we know if there is a second triangle? Okay, so we went back for a sec, In this example right here, we did not have a second triangle, and the reason that we didn't is because when we did the 180 minus 40, we got this number, and when you add these together, you've gone past 180. So that's how you know it's impossible. On this example, though, if we add 137.6 to 135, we're not going to go past 180. Okay, we actually get 172.6 degrees. That means we still have leftover room for this third angle. Okay, this third angle, we could get it by 180 minus that, and that gives us 7.4 degrees. So it is possible to have a second triangle because there are two different numbers that have a sine of 0.67. One of them is 42 degrees, one of them is 137 degrees, and if we use the 137 degrees, we add it to 35, we haven't yet used up all degrees in the triangle. Okay, so here's the main idea. How do I know if there's a second triangle? What you should do first is write out your answer completely to the first triangle. Okay, to find out if there's a second triangle, copy down the information they gave you. They gave us those three things. They told us for sure right here. They told us right here that those things for sure are part of our triangle. For the remaining stuff, how do we find the missing stuff? We start by seeing if this angle plus this angle is still less than 180. How do we even find this 137 angle? We took this one and we did 180 minus that angle. Okay, the reason we did that is there are two angles that have a sine of 0.67. One of them is the 42 degree angle, and the other one is gotten by finding 180 minus that, which is 137. If you find this second angle, okay, and you have to subtract it from 42 because in this process that we did right here, we started by finding 42. 42 was angle B. We had to start with angle B because they didn't give us angle C. Okay, if you start by finding B, you do 180 minus that. If this number and this number do not add up to 180, then you find this third angle to make it equal 180. 35 plus that plus 7 is 180. And if that works, if you haven't gone to 180 yet, you do have a second triangle. Okay, then we can find this third side by using the law of sines again. So that's a little bit confusing the first time people do it when they have multiple triangles, but the main idea is to take 180 minus the angle that you found, and if that gives you two angles that do not yet reach 180, then you know that you can keep going. Okay, let's do one more example. This is a baseball example. It says a baseball is hit between second base and third base. Okay, and it's caught at point B right here. So you form this triangle. How far away from second base was the ball caught? Well, obviously we can't have two triangles here because they gave us a triangle. So we don't know this part right here, how far away from second base. So we'll call that X. So we can say this. We can say, well, first of all, they're giving us 2 out of the 3 angles in a triangle. So if we add those together and subtract from 180, 43 plus 65 is 108. And 180 minus 108 is 72, so that will help us. Okay, so we can do sine of 43 over its side, which is over x, equals, and then this is 90 feet, so let's use that. And its opposite angle is 72. So sine of 72 over 90. Then let's cross multiply. We get x times the sine of 72 equals 90 times the sine 43. We'll divide everything by sine 72. And when we do that, we're going to get x is equal to whatever that is right there. And it should probably be less than, not probably, it should be less than 90 feet because 72 is the largest angle there, which means 90 feet would be the largest side. So if we're opposite a 43 degree angle, we should have a smaller number. So 90 sine 43, and that's divided by sine of 72. Let's make sure I typed that in correctly. Yep, sine 72. We get 64.5 feet. Okay, so that is section 12.4, which is on the law of sines.